6 o'clock in the morning, getting set for another day. Another chance to change my story. I believe in my hustle. I know be lazy person, oh. But life is just a knock me goes. If it don't close, I go find another. If I fall down, I go try to recover. If it never walk me, I know they bother.
Good morning, ladies and gentlemen, and everyone watching me out there. This is another edition of Tele with Aquinas. Today we are going to look at a certain topic which is going to benefit our junior brothers in the GHS as well as our brothers in the SHS. The name of this topic is rational numbers. Rational numbers. Rational numbers. Yes. And under it, we are going to look at fractions. Fractions. Yes. Although it's a JHS topic, yet most SHS students are still having problems solving questions that involves fractions. So that is what we are about to look at today. So I want both the junior high school and the senior high school students to look at it very well and see where they don't understand. They look at it well, and I believe by the grace of God, by the end of this lesson, you will understand something. What is a fraction? That's the first question we should ask. Fraction means part of a whole. Part of a whole. Whole. Look at the spelling of whole. Whole means something that has been combined, like one. Something that is one. Not one as in one, but one as in something that has been put together, a whole. Very good. So part of it, for example, part of a circle. This is a circle. This is just one circle. And it's a whole circle. It is not a half circle, it's a whole circle. So that is what we call a whole. Dividing this circle into equal parts, let's say 4 equal parts. This is what it's going to be. You cross here and then you cross here like this. You have 4 equal parts. So that is the meaning of what? Fraction, part of a whole. Now, let's look at something. The way we represent fractions, as you know already. A over B. The number on top is called the numerator. Numerator. And the number down here is called the denominator. Denominator. I think you know this already, but I'm using it to explain some points to you. Very good. What does the numerator stand for? Because I've said a fraction is what? Part of a whole. Part of a whole, part of something. Part of an item. One item. Yes, part of something. So, the number on top is called the numerator, and what does it represent? It represents, no, let me go to the denominator first so that you understand the numerator better. The numerator is telling you, the denominator is telling you the number of times the item has been divided. The number of times the item has been divided. That is the denominator. And the numerator is telling you the part of the equal divisions that has been put together. For example, 4. 1 is representing a whole, and it has been divided 4 times. So among the 4 times, this one you are seeing is representing one of them. So when you divide a whole thing into 4, you have this. It means you have divided it into 4 equal parts. 4 equal parts. And writing just 1/4 means you've selected just one of the divisions. So this is called 1/4. It means there is something that you have divided 4 times, and this is one of the equal divisions. Watch a day be move 4, and only 1/4. That's the meaning. So the one here is telling you that after we divided a certain item 4 times, this is one of the 4 divisions. If you write this 3/4, it means it is 3 of the 4 divisions. The 4 here is telling you that you divided the thing 4 times. And the 3 on top is telling you that after you divided the thing 4 times, you've combined 3 of them. Like you've combined this one. 1/4 plus 1/4 plus 1/4. This one will give you 3/4. It means after we divided it 4 times, we have combined 3 of them. So the 3 here is telling you that. Let's look at example. 2/5. The 5 is the denominator. And what it is telling you is that a certain item has been divided 5 times. And the 2 here is telling you this one is what? 2 of the 5 divisions. We have put 2 of the 5 divisions together. Because if you divide something 5 times, you get 1/5, 1/5, 1/5, 1/5, 1/5. Like this. So 2/5, the number on top is telling you that after dividing the thing by 5, you have put together 2 of the equal parts that has been divided. Very good. Now let's continue. By the way, all these are called common fractions. Common fractions. Now let's look at the type. Let's quickly run through the types of fractions because, as I said, most of you know them already. The first type that we are going to look at is called proper fraction. Proper fraction simply means if you get a fraction which the numerator is, let's use A to represent the numerator as we did here, and B to be the denominator. For proper fraction, the numerator is smaller than the denominator. For example, 2/5. The numerator is smaller than the denominator. So this one is what? A proper fraction. 1/2. 3/7. These are what? Proper fractions. The next one is what? Improper. Improper fractions. The opposite of this one. The numerator is bigger or greater than the denominator. Example, 7/4 is an improper fraction. 8/5 is also an improper fraction. Any fraction that you can see that the numerator is bigger than the denominator, the number on top is bigger than the number downwards, is called improper fraction. Now let's look at another one, like, and this one is very important. Please concentrate here and look at something. Like fractions. Like fractions. When we say 2 fractions or 3 fractions or more fractions are liked, they are like. That's where the word is coming from. Like. So liked fraction, they look the same. So if you say 2 or more fractions are liked, it means they are having a common denominator. The denominator is the same. The denominator is the same. Look at this. Look at this. These fraction. Why? Because they are having the same denominator. The opposite of this is unlike fraction. Obviously, you can know if like they are having the same denominator, unlike they are having what? Different denominators. So fractions that are having different denominators are called what? Unlike fractions. Now let's go on. And then another important type is called mixed fraction. Mixed fraction. It's a combination of a whole number and then a fraction. For example, so mixed fraction. You will be seeing this more often in examples that will be given to you. Look at this. 3 whole number, 2/5. It is called mixed fraction. It is called what? Mixed fraction. Why? We have a whole number plus a fraction. So we will get to the simplification of these things. So you know, but I'm telling you, this guy is called what? Mixed fraction. Alright. Now we are going to another item. Yes. We are going to look at the simplification. We are starting with the simplification of what? Fractions. My dear brothers, my junior brothers in the JHS should, pay critical attention to this one. We are going to how to simplify fractions. We are going to how to simplify fractions. We are going step by step. Look at this. 12/16. It is a fraction. And of course, it is a proper fraction. If you are given this to simplify, what they want to tell you that this is not in its simplest form. It is not in its simplest form. The reason why it is not in its simplest form is that 12/16, there is a certain number that you can use to make 12 smaller and also make 16 smaller. So you have to look for that number. There are so many numbers that you can use. From here, you know you can use 2 because 2 can go into 12 and then 2 can go into 16 equally. Of course, any number can go into 12, but we want a number that can divide 12 equally without any remainder. That's what we are talking about. So maybe you don't know the number to choose, but the best thing is to look at the factors of both. I know you've done highest common factor and other things. So these are the numbers that can divide both, are called what? The factors. So after getting a number that can divide this one, you have to make sure the same number can also divide this one. So me, for the start, maybe I don't know that, maybe I can use 4. I don't know. Let's say I don't know that I can use 4. But I know that I can use 2. So let's go bit by bit. 2 can go here how many times? 6. And then 2 can come here 8. But tell yourself, is that all? Can't you find another number that can go here and go here at the same time? Of course you can. And that same number is what? 2. 2 can go here 3, and then it will go here 4. After getting to this point, you know no number can go here and go here at the same time. So by so doing, this one becomes your final answer. 3/4 becomes your final answer. So simplifying it means you are breaking it down to the point that no number can be divided no number can divide both numbers. That's the numerator and then what? The denominator. There are so many simplification examples that you can set for your own self. 6 over 9. What number? When I see these numbers, I know that 3 can go here 2, and then 3 can go here what? 3. So this is called what? Simplification or breaking it down. So as I said, you can set more examples for yourself and then do it. Let's do the last one on this. 24 over 36. So looking at 24, of course you know the factors of 24. 1, 2, 3, 4, 6, 8, 12, 24, the factors, you know them already. But if a bigger number is going to be difficult for you, don't worry yourself with a bigger number. Go step by step. By looking at the numbers here, you've done tens and ones, hundreds and other things. Look at the number here. It's representing ones. And this one is representing tens. So after seeing 4 and 6 here, I know I can divide by 2. I can divide both of them by 2. So why don't I start with 2? Why don't you start with 2? If you know that any other number will be okay for you, like 4, you can also, help yourself, or 6. But maybe you don't know these bigger numbers. You know the smaller ones. You can start with a smaller one. You know that 2 will go here 12. 2 will go here what? 18. You have this. At the end of it, you can see 2 and then 8. It means 2 can still do more work for you. 2 will go here 6. 2 will go here what? 9. At the end, 6 here and then 9 here as we did earlier on. What should you choose? 3. 3 can go here 2 and then it can go here 3. So the final answer is what? 2 over 3. As simple as that. Please, don't worry yourself with bigger numbers. If you know that the smaller number will do the work for you, please go for the smaller number and do it bit by bit. You know that in the JSS, you people are not using calculators. And therefore, if you are using bigger numbers and you are not careful, you get your work wrong. I hope you understand. So, this, in actual fact, is called what? Breaking it down, or what? Simplification. Breaking it down to their simplest form. Breaking fractions down to their simplest mathematics that you should know. Mathematics is a very, very good subject. It's a very interesting subject. But one thing it doesn't like is a lazy student. It needs constant practice. If you understand, maybe you didn't understand this one initially, but now, by the grace of God, you understand. If you just understand this one alone, and then go and put your book somewhere, without practicing it constantly, you are going to forget everything. It will be like you've not seen it before. That's the nature of mathematics. So those of you who have been complaining that math is difficult, that is your problem. If you understand this one, you need to go home, take your book again, and start solving. In fact, you have to set questions for yourself. For example, you can set about 1,000 questions on this particular subtopic. You understand? You can set about 1,000 questions for your own self. When it comes to what? Simplification. You can just take your jotter and write, 15 over 45. Then you start. Okay, what can I do? Should I use 3? 3 is good, but can I get a bigger number? Oh no, I cannot get a bigger number. Then let me use 3. 3 will go here 5. go here 15. Okay, where are you? 5 can go into itself and go here as well. So 5 goes here 1 and then here 3. That's all. You know that it's 1/3. So practice it. Just close your eyes and write a question for yourself and solve. Don't just say, oh, I'm now good to go, so you put your book somewhere. The next time you come and visit the book, you forget everything. And then you start complaining that math is difficult. Okay, let's continue. Now let's go to how to simplify mixed and improper fractions. How to simplify mixed and improper fractions. How to simplify mixed and improper fractions. For example, 3/2/5. The law says you should take 5 here. That is the denominator of the fraction. Use it to multiply the whole number. After that, add the results to the numerator of the fraction. That is how to simplify it. So if you have been given this and they said you should write it in another form, in fact, it was initially an improper fraction. That is why you came to get this. But maybe you have to take it back to the improper way. So 5 times 3 will give you what? 15. Then the 15 that you get plus the numerator, which is 2. So you get 17 over the denominator, 5. Another one, 3/7. The denominator here will multiply the whole number, so 4 times what? 7. It will give you 28. Then plus the numerator, 30 what? 31. So 31/7. All these you can see are improper fractions. They are all improper fractions. They are all improper fractions. Solve this whilst you are watching. 7 whole number 2/3. 7 whole number 2/3. Write it as an improper fraction. I'm waiting for you. Maybe. All right. I hope you were able to solve it. The correct answer is you are going to use this 3 as the denominator to multiply the whole number. So 3 times 7, you get what? 21. And after that, you will add the 21 to these 2, which is the numerator. So you get 23/3. Very good. Very good. Now I want us to look at operations on rational numbers and subtract fractions. Look at it well. A/B plus C/D. Students have a problem adding most times. You cannot add numerator plus numerator, denominator plus denominator. No, you don't do it that way. It has its own arrangement. It has its own way of doing it. That is what we are about to do. The only thing you can do most at times is to add only the numerators when the denominators of the fraction are the same. For example, 2 over 5 plus 3 over 5. These are like fractions. Because the denominators are the same, you can go ahead and add the numerators. So because the down numbers are 5 and this one is also 5, I can just go ahead and add this one and get 5, then over 5. This one will give me 1. But I want to use a more, let's see this. 2 over 7 and then 3 over 7. The denominators are the same, so I can just add the top number, that's the numerators. I'll get 5 over 7, like this. Both of them are having the same denominator, so you can add the numerators. So this is the only situation that you can add. If the denominators are not the same, you cannot add just like that or subtract. I can also subtract. In fact, I didn't do that for subtraction. For example, 4 over 7 minus 3 over 7. Both of them are having the same denominators. So I can just go ahead and subtract the numerator. So 4 minus 3 will give me 1 over what? 7. Only when the denominators are the same, only when the down numbers are the same, that is when you can subtract. Let's go to a typical example. Example 1. 1 over 2 plus 2 over 5. We've been given these fractions to add. The first thing we should look at is the LCM of the denominators. So you are going to rule your line here like this nicely, and then you are going to find a common number between these two numbers. That's the denominator of this fraction and then the denominator of this fraction. This is 2 and this is 5. What is the LCM between them? And I'm going to tell you the secret about LCM. LCM simply means the least common multiple. You can say 2, 4. What it means is that the first one is what? 2. And it is the first number. It means 2 times 1. The position is 1. So 2 times 1, 2. 2 times 2, 4. 2 times anything that you already say 2. 2 times 3, 6. 2 times 4, 8. How many numbers do we have? We have 4. So that's what 2, 4, 8. 2, 5, 10. I hope you get it. So these are what? Multiples. And it has no end. It can go till you get to worry about 2, 6, 12. It is what? Indefinite, infinite, whatever you want to use. And then you come to 5. The multiples of 5. The first one will be 5 because 5 times 1 is 5. 1 because it's the first one. The second one means second means 2. So 5 times 2, 10. The third means what? 3. So 5 times 3, 15. 20 is also what? Indefinite or infinite. And then you look at what is common among them. You can get so many. In fact, if we should continue, it's because we ended here, we ended at 12. The next one will be 14, 16, you get to 20. And so many numbers will be common amongst these two. That's for 2 and then for 5. Numbers will be never as number. So many numbers will be common. After putting the common ones down, you look at the smallest amongst the common ones. And the smallest you can get is 10 because, see, after writing 5, you cannot find 5 here. The smallest of the multiples of 5 is 10. And that's the one that 2 is having. The smallest is 5, although, but the common one for 5 is 10. Continuing here, you get 20. But 20 is bigger than 10, and you want the smallest one. That's what we call least common what? Multiple. Least common what? Multiple. I hope I'm making sense. So, looking at this, you put the LCM here. So the LCM for 2 and then 5 is what? 10. The simplest way, if you don't want to go through this process, the simplest way, if you get the two numbers, the two denominators, look at them carefully. Can one or can the smaller one go into the bigger one? If the smaller one can go into the bigger one, then you can take the bigger one as the LCM. Are you listening? If the smaller one can divide the bigger one without a remainder, then automatically the bigger one becomes what? The LCM. If the smaller one cannot go into the bigger one, and if you don't want to waste your time, just go ahead and multiply. Look at this. For this example, 2 cannot go into 5 equally or without a remainder. And therefore, I can choose to multiply 2 and then 5 and get 10. It will become the LCM. Don't worry, we are going to take more examples so you appreciate what I'm doing, you understand. So, you say because you multiply 2 and then 5, 2 goes into 10 how many times? It means if you divide 10 by 2, what will you get? That's the meaning. So they normally say 2 goes into 10 how many times? The real meaning is if you divide 10 by 2, 2 goes into 10 how many times? It means if you divide 10 by 2, what will you get? You get 5. After getting 5, you use 5 to multiply. You use 5 to multiply whatever number here, the numerator. So 2 goes into 10 5 times. Times 1, you get 5. 5 goes into 10 how many times? 2 times. Times 2, you get 4. 5 goes into 10 2 times. This 2 times the numerator, you get 4. Now you can add 5 plus 4, 9 over 10. And this is a proper fraction. It becomes your final answer. Now let's go on and take another example. 3 over 4 plus 7 over 8. As I was saying, they have different denominators, so you cannot add anybody unless you find the LCM. What is the LCM? Look at the two numbers. Can the smaller number divide the bigger number equally? Ask yourself that question. Yes, it can. 4 can go into 8. If it can go into 8, it means 8 will become the LCM. There's no need for you to worry yourself. Once 4 can go into 8, then 8 is your LCM. Then you write 8. So 4 goes into 8 how many times? 2 times the number here. So 4 going into 8, you get 2. You use 2 to multiply 3, you get 6. 8 goes into 8 once. So 1 times 7, you get 7. Then the final result, you get 6 plus 7, 13 over 8. This is an improper fraction. And as a matter of fact, you don't have to leave your answer this way. You need to break it down. 8 cannot go into 13 equally. There will definitely be a remainder. So we are going to write the remainder as well and get what? A mixed fraction. So 8 will go into 13 how many times? Just once. If 8 goes into 13 once, what will be the remainder? It will be left with what? 5. So you write the remainder 5 here, then over 8 like this. I hope you get it. Now let's take another example which involves 3 fractions. 1 over 3 plus 2 over 9 minus 3 over 4. Let's look at this example. All the LCMs are different. So just rule your line. Sorry, all the denominators are different. So just rule your line and come and look for the LCM. Tell yourself, what is the LCM? Look at the 3 denominators. And I'm going to give you a story. 3. The senior brother of 3 is 9 because 3 is one of the factors of 9. So 3 and 9, they know each other. I hope you understand the story I'm making. But 4 is a stranger. 4 is a stranger. So let's say there is a fight between 2 families. This and this one, they are family members. So the bigger brother will go into the fight for the family. So finding the LCM is going to be between 9 and 4. Why? Because 3 is already a factor of what? 9. So you focus on what you are going to get here. 4 is smaller than 9. But can 4 go into 9? No. 3 can go into 9. So I will choose 9. If it were to be this one and this one, I would have chosen 9. Because 3 can go into 9. But 4 cannot go into 9. So I'm going to multiply. I'm going to multiply what? 9 and then what? 4. Multiplying 9 and 4, you get what? 36. So 36 will be your best choice for LCM without wasting time. Because at the end of everything, you can break it down. So don't worry yourself. When you see a number that cannot go into the bigger number, just multiply. Just multiply them. If it can go into it, choose the bigger number. At first, 3 numbers were going into the play. But 3 can go into 9, and therefore 3 becomes the junior brother of 9. So 9 will go into the fight for 3. So this one cannot go into 9. If this one were to be maybe 3, another 3, I'm like taking for example, then the whole LCM you can choose 9. But this one was 4. And 4 cannot go into 9, so you have to multiply 9 over 4 and get it. Now let's go to the main work. 3 can go into 36 how many times? It can go into it 12 times. Once you know 3, 1, 3, and 2, and 2, you don't have any problem. As they say, 36 divided by 3, that's what they want you to know. 36 divided by 3 is 12. 12 times 1, you get 12. 9 will go into 36 how many times? 4 times. It's the same as 36 divided by 9, 4. Times 2, you get 8. Minus 4 can go into 36 how many times? 9 times. So 9 times 3, you get what? 9 times 3, you get what? 27. Very good. Now let's solve the one on top. 12 plus 8, 20. 20 minus 27, negative 7 over 36. This is a proper fraction. After that, go back and see. Go back and see. If 7, the smaller number, can go into 36. Can it go? No, it cannot. So you leave your answer like that. So that is the story of LCM. If the numbers are bigger, and you say you are going to waste your time to write all the factors and the multiplication or the multiples down, you end up wasting your time. And at the end, you may not be able to choose the right LCM. So take this particular point that I'm telling you. If the two denominators, or there are 3, and all of them can go into the bigger number equally, then choose the bigger number as the LCM. If the smaller number cannot enter the bigger number, then multiply the two of them. It will give you your LCM. Now, I want us, alright, so I'm going to give an example that involves mixed fraction. An example that involves mixed fraction. Now take a very good look at this what? Mixed fractions. Now let's start. We are going to turn the mixed fraction into improper fraction. 2 will multiply 3. You get 6. Plus 1. You get what? 7 over 2. Plus, let's come here. 3 will multiply 2. You get 6. Plus 2, you get 8 over 3. 2 is smaller than 3, but 2 cannot go into 3. So you multiply the two of them. You want the LCM. So you multiply the two of them, you get 6. So 6 is the LCM. 2 goes into 6 how many times? 3 times. After all, you multiply both of them. You don't mean to multiply it. We should become 2. So let's go. 2 will go here 3 times. 3 times 7 is what? 21 plus 3 will go here 2 times. 2 times 8 will give you what? 16. So 21 plus 16, you get what? 37 over 6. This is an improper fraction. You can turn it into what? Mixed to get a full mark. So let's start. Look at this. 37. 6 can go here how many times? Then you start to count in your head. 6 1 6, 6 2 12, 6 3 18. Then you go to 24. Then you see that the last number you get is 6. And 36. 6 goes into 37 what? 6 times. So 36, it will be left with what? Remainder 1. Over what? So, ladies and gentlemen, we've come to the end of another edition of Tele with Say Aquinas. And I've given this example on the board. Today we tackled addition and subtraction. We were on operations. So we've done addition and subtraction. So I want everybody to go and look at this question. Sit down and solve it. The LCM issue will come into play. And then you will know how to go over it. Yeah, yes. You will know how to go over it. So look at the question. Solve so that the next time we meet, we will continue from here. We will continue from multiplication and division of fractions. And then we go to board mass. We go to board mass. Board mass simply means putting all these operations together, plus brackets and other things. So after that, I believe that you understand everything. Solve this question so that when we meet again, we all solve it together and use the solution that I will do to check yourself whether you've gotten it right or wrong. Thank you very much. I will meet you again.